Hello everyone. Despite COVID-19, we are going to continue our discussion on telco softwarization. In today's discussion, we are going to look at what are the standards related to SDN especially, and what are the implementation options that we have to implement SDN. SDN related standard developing organizations. Now when it comes to SDN, we have several standard developing organizations defining SDN and also releasing standards related to SDN. The first one that comes to our mind is Open Networking Foundation, or in short ONF. Then we have IETF, or Internet Engineering Task Force drafts and RFCs, requests for comments related to SDN. One working group working especially on SDN is the IETF Software Defined Networking Research Group, but that is a concluded research group. And then we have ITU, or International Telecommunications Union, where we have multiple standards like ITU TY3320, which was released in 2014, which discusses about requirements for applying formal methods to software defined networking. Then we have another ITU T standard, which is Y3302, which was released in 2017, about functional architecture of software defined networking. And then we also have Y3301, which was released in 2016, about functional requirements of software defined networking. And also Y3300 in 2014, the framework for software defined networking. So these are some of the standards that we have and that we use for SDN. Now, out of these standards or standard developing organization, ONF, or the Open Networking Foundation, is quite special. If you go and check the type of deliverables the ONF has delivered over the years, we go back in 2011, where actually the standard or the definition of SDN was released as decoupling of the control and forwarding planes, enabling network control to be directly programmable. So this is one of the initially defined definitions, and still the industry uses this definition by ONF to define what is SDN. There are certain challenges and certain discussions against this definition, but still we accept the fact that the decoupling between the control plane and the forwarding plane is actually the starting point in programmable networks, or hence SDN. And then in 2012, ONF also started working on Open Flow as a protocol, and it is the first standard communications interface defined between the control and forwarding layers of an SDN architecture. So since 2012, ONF is supporting the work of Open Flow. And by the way, as I have already mentioned, Open Flow is not the only southbound protocol that we have for SDN, but there are several other protocols, but Open Flow is one of the initial protocols that we started using. And then in 2014, Open Network Operating System was introduced by ONF. SDN operating system for a service provider with scalability, high availability, high performance, and abstractions to create apps and services. So basically, ONOS, or Open Network Operating System, is an implementation of an SDN controller. We'll look at what are the options that we have to implement an SDN controller, but ONOS is one of them. And in 2016, CODE was introduced. CODE stands for Central Office Re-architected as a Data Center, and it actually transforms the network edge into an agile platform for service delivery. what basically it does is convert the existing central offices or local exchanges to a mini data center where actually we use a lot of virtualized version of network functions instead of using multiple physical network functions. And the work of ONF continues because we are now in 2020. Since 2016, there were several developments within ONF and the work continues. So when it comes to SDN, it is not just SDN as software defined networking, but we have a whole lot of other things, the open flow protocol, SDN controller implementations, and taking SDN further in the network and things like converting central offices to mini data centers, like concepts like code and several other things. So this is how ONF has been doing their work. Now, one of the key components of an SDN architecture is the SDN controller. If you go back in one of our previous knowledge sparks on SDN, if you can remember this picture, you understand that basically we are talking about two things in SDN. One is the network element. In this case, we are using an open flow enabled network device and multiple devices, of course. And then we have a controller, SDN controller, to control these things. Because if you can remember, you separate the control plane from the data plane. So your data plane or the forwarding plane is within the network device, and your control is now centralized, logically centralized within the SDN controller. So one of the key components in any SDN architecture is the SDN controller. So what SDN controller to use? Of course, you have to use a SDN controller, but what are the options that we have in terms of selecting an SDN controller? So if you look at in very broad aspect, if you look at the SDN controller implementations, we have basically two ways. One is closed source or proprietary ways of implementing SDN controllers, and the other option is to use open source. Now, of course, closed source proprietary could come from a vendor, or you can have your own proprietary, but it's very unlikely. And when it comes to open source, of course, you can use open source directly. If you are a service provider, you can just download the source code on the relevant SDN controller, and then you can just use it. But otherwise, we have a lot of vendors supplying SDN controllers based on open source implementations. Now, within open source, we can actually categorize SDN implementations as single instance SDN control implementations, which includes early SDN controllers like Knox, POX, RYU or RYU, and then Beacon, and also Project Floodlight. These are called single instance SDN controllers because you run just a single instance of the control function. And then, of course, you have multi-instance SDN control implementations. This includes the popular ones like ONOS, which we discussed a few minutes back, and ODL, which stands for Open Daylight, and also Tungsten Fabric, and also Open Contrail. Now, if you take ONOS, ODL, and Tungsten Fabric, they are all within, or rather managed under the Linux Foundation. And ONOS, ODL seems to be the popular ones among service providers especially. So that's about SDN standards and the implementation options to implement SDN controllers. I hope you now understand what are the organizations defining SDN and what are the standards associated, and what are the options we have to implement SDN controller, which is one of the, or rather the main critical component in an SDN architecture, and the options that you have. Hope to see you in another Knowledge Spark discussing further onto telco softwarization. Bye for now.